The helmet visor shatters. Shards of glass spray across the soldier's face as the display flickers red, targeting boxers, blue friendly markers, all gone. What's left? A cracked screen and enemies 30 meters away that were supposed to be highlighted in red. Afghanistan, 2022. The AR system that promised to turn every soldier into a superhuman fighter just turned him blind. He rips the headset off and goes back to what works his eyes. The Pentagon had spent 8 years and $22 billion developing combat AR glasses that was supposed to end fog of war forever. Every threat marked, every ally tracked, perfect battlefield awareness. But that shattered visor revealed something nobody wanted to admit. And 3 years later, soldiers are still refusing to wear them. The year 2018, Microsoft wins the contract. IVA, a centigrated visual augmentation system. The pitch sounded like science fiction. Soldiers see through walls using thermal imaging. Enemy positions appear as red outlines. Friendly forces glow blue. Navigation arrows float in your vision. Ballistic calculations happen instantly. One sergeant described the promise. It's like having a video game HUD in real life. Congress loved it. $22 billion approved. 120,000 units ordered. Deployment target 2021. The technology worked perfectly in laboratories. Soldiers in Virginia testing facilities called it revolutionary. Defense contractors showcased flawless demonstrations. Then the Army sent prototypes to actual combat units for field testing. That's when everything collapsed. But the collapse wasn't what you'd expect. It wasn't the technology that failed first. Fort Drum, New York, 2021. First extended field trials. Soldiers wore the headsets for 4 hours during training exercises. Within 90 minutes, reports started flooding in. Nausea, dizziness, splitting headaches. Some soldiers vomited, others couldn't maintain balance. The Army's own testing data showed 80% experienced physical discomfort. The problem: your brain isn't built for digital overlays on reality. When virtual images don't perfectly align with what your eyes see naturally, even by millimeters, your neural system fights itself trying to reconcile the difference. Microsoft called it a calibration issue that could be fixed. They adjusted the optics, refined the display angles, tested again. Same result. Soldiers got sick. But here's what made it catastrophic. Discomfort wasn't just annoying. In combat, nausea and dizziness mean death. A soldier who can't maintain balance can't fight. The Army had a choice: fix the comfort problem or abandon the program. That's when they discovered something worse than discomfort: night operations. The AR system's greatest advantage: thermal imaging highlights enemies in complete darkness. Except the screen glow gives away your position like a flashlight. Enemy combatants in Syria described it to intelligence officers. American soldiers were easier to spot at night because of glowing faces. The screens that were supposed to provide advantage became beacons. Engineers tried dimming the displays. Two dim soldiers couldn't read the information bright enough to read visible to enemies. They tested different wavelengths, polarization, brightness, algorithms. Nothing worked. Physics 1: a screen bright enough to see is bright enough to be seen. The Army considered making the system exclusive to daytime operations. But if it only works in daylight, what's the advantage over regular combat optics? Then field commanders reported something that made the visibility problem look minor: Helmand Province simulation. Enemy contacts appear as red boxers, friendly forces as blue, civilians as yellow. Navigation waypoints as green arrows. Ammunition count in the corner. Heart rate monitor. Compass bearing. Temperature. 18 separate data streams fighting for attention in your field of view. A sergeant from the 82nd Airborne described it: "I spend more time looking at icons than looking at threats." The system that was supposed to enhance awareness was creating tunnel vision. Soldiers fixated on the display, missing actual visual cues. The Army tried simplifying the interface. Fewer icons, less data, but reduce it too much, and the system loses its advantage. Keep too much, and soldiers can't process it. They tested adaptive displays that showed information only when needed. The AI decided what mattered. That created a new nightmare. What if the AI is wrong? In a firefight, you can't trust software to decide what's important. That's when the testing revealed the fatal flaw nobody anticipated. The AR system identifies a target. Red box appears. Threat detected. The soldier aims. Before he fires, he lifts the headset to confirm with his actual eyes. It's a civilian carrying a shovel. The system tagged it as a weapon. This happened repeatedly during trials. False positives. Misidentified threats. Friendly forces marked as enemies when GPS signals bounced. The technology that was supposed to provide certainty created doubt. Soldiers stopped trusting the displays. They'd see a red box and check manually before engaging, which defeats the entire purpose if you're verifying everything visually anyway. Why wear the headset? Lieutenant Colonel Christopher Snyder testified to Congress. Soldiers preferred removing the system entirely rather than fighting with unreliable information. The Army had spent $22 billion on technology soldiers refused to use, but Microsoft insisted the problems were solved. They just needed more development time. That's when the Senate started asking uncomfortable questions. In 2023, Senate Armed Services Committee hearing, Senator Warren asks the obvious question. Civilian AR glasses exist and work fine. So why can't the military version? Microsoft's HoloLens, Apple's Vision Pro, Meta's Quest, commercial products that don't cause nausea, don't glow in the dark, don't overwhelm users. Why couldn't military AR just use that technology? The Army's answer revealed everything. Commercial AR works in controlled environments, offices, homes, warehouses. Combat means 120-degree heat, freezing rain, dust storms, explosions, equipment that falls off trucks, systems that get hit by shrapnel. Commercial devices fail in military conditions before the comfort issues even matter. But here's what breaks the comparison completely. Commercial AR doesn't need to be trusted with life and death decisions. If your Apple Vision Pro misidentifies something, you're annoyed. If military AR misidentifies a target, someone dies. The tolerance for error is incomparably different. And that brings us to what's actually happening with these systems right now. Will soldiers fight using augmented reality glasses? Yes, but not how anyone imagined. They're being used right now, just not in combat. Training facilities, maintenance simulations, vehicle repair guidance, medic instruction, all the roles where mistakes aren't fatal and discomfort is tolerable. The Army quietly shifted IVAs from frontline combat to support roles. They're not calling it a failure, they're calling it phased implementation. Translation: works where you don't need it most. The UK tested similar systems. Their assessment was direct, suitable for logistics and training, not close combat. Israel deployed a R4 tank crews in closed spaces where screen glow doesn't matter and information overload has context. It works there. What they won't do: replace human vision in infantry combat, operate reliably in variable conditions, eliminate the need to verify threats manually. The problem isn't that the technology is bad, it's that combat demands perfection the technology can't deliver. You can't fight effectively while nauseous. You can't hide while glowing. You can't trust systems that misidentify targets. After $22 billion and 5 years of development, the AR glasses that were supposed to create superhuman soldiers became expensive training aids that sometimes cause headaches. That shattered visor in Afghanistan wasn't a freak accident. It was proof that overlaying digital information on reality works perfectly until reality fights back. And in combat reality, always wins. Sometimes the human eye is the only sensor you can trust.